Hi, welcome everyone. In this session, we will discuss on computer system architecture. To truly understand how an operating system manages resources, we must first look at the different ways those resources, specifically the processors, are organized. Computer systems are categorized based on the number of general-purpose processors used. We will explore three primary architectures: single processor systems, multiprocessor systems, and clustered systems. Let's begin with the most basic form, the single processor system. Historically, most computer systems used a single main central processing unit capable of executing a general-purpose instruction set, including instructions from user processes. You might notice that even older systems have disk or graphics controllers. However, these are special-purpose processors with limited instruction sets. They do not run user processes and act as subordinates to the main CPU. The operating system sends them tasks which they execute autonomously, but the core intelligence of the system remains with the single main CPU. Today, single processor systems are increasingly rare. Most modern computing, from smartphones to high-end servers, uses multiprocessor systems, also known as parallel or tightly coupled systems. These systems feature two or more processors in close communication, sharing the computer bus and often the clock, memory, and peripheral devices. There are three main advantages to using multiprocessor systems. First is increased throughput. By adding more processors, we can complete more work in less time. However, the speedup is not perfectly linear because of the overhead required to keep the processors synchronized. Second is the economy of scale. These systems cost less than multiple equivalent single processor systems because they share peripherals, mass storage, and power supplies. Third is increased reliability. If functions are distributed properly, the failure of one processor will only slow the system down rather than halting it. This is known as graceful degradation. Some systems are even designed to be fault-tolerant, meaning they can suffer the failure of any single component and continue operating. There are two primary ways to organize multiple processors. The first is asymmetric multiprocessing, which follows a boss-worker relationship where one processor schedules and allocates work to the others. The second and more common model is symmetric multiprocessing, or SMP. In SMP, each processor is a peer and performs all tasks within the operating system. While this allows many processes to run simultaneously, the operating system must be carefully designed to ensure processors do not conflict when accessing shared memory. In modern computing, we often see multi-core designs, where multiple computing cores reside on a single chip. This is highly efficient because on-chip communication is faster and uses less power. We also consider memory access patterns. In Uniform Memory Access, or UMA, any CPU can access any RAM in the same amount of time. In Non-Uniform Memory Access, or NUMA, a CPU can access its own local memory faster than the memory of other CPUs. In these cases, the OS must be NUMA-aware to schedule processes effectively. Finally, let's discuss clustered systems. While multiprocessor systems are tightly coupled, clustered systems are loosely coupled. A cluster consists of two or more individual systems, or nodes, joined together via a local area network or a fast interconnect. The primary goal of clustering is high availability. If one node fails, others can take over, which is vital for databases and web servers. Clustering can be asymmetric, where one node is in a hot standby mode, monitoring the active server, or symmetric, where all nodes run applications simultaneously while monitoring one another. Some parallel clusters allow multiple hosts to access the same data on shared storage. This requires specialized cluster software and a distributed lock manager to ensure that multiple nodes do not corrupt data by writing to the same file simultaneously. In summary, the architecture of a computer system significantly influences how an operating system is designed. Single processor systems are simple but limited. Multiprocessor systems, particularly SMP and multi-core, provide performance and reliability but require complex synchronization. Clustered systems provide the highest level of availability and can scale to massive sizes. Thank you for your time. See you in the next session. Bye.